Hello everyone, and welcome to the Mathematecher channel. Division is the fourth arithmetic operation that we have all studied in primary school for calculation purposes. However, when it comes to do real mathematics and build a theory, it's imperative to consider it from a logical and theoretical point of view, and to study its properties meticulously. In today's video, we're going to see how to prove the logical proposition that characterizes the Euclidean division. This proposition affirms that if a and b are two different from zero natural numbers, then there is one, and only one pair of natural numbers that we can note, q and r, such that a equals b multiplied by q plus r, and r is strictly lower than b. Despite the fact that this proposition seems intuitive and obvious to the point that there is no need to demonstrate it, its proof is really important and relies and showcases a fundamental axioma upon which most of elementary arithmetical theory is built. So in order to prove this proposition, we will have to prove the existence and the unicity of the two natural numbers, q and r, knowing that a and b are both different from zero natural numbers. Hence, let's note, capital S, the set of numbers that are lesser than a and that can be written as b multiplied by q, such that q is a natural number. According to the upper bound axioma, if capital S is a non-empty underset of a superset, that we can note capital P, and that there is an element P of the set capital P, such that P is greater than any element S of the set capital S, then there would be an element that we can note S prime of the set capital S, such that S prime is greater than any element S of the set capital S. Now, if we consider the set we defined, which is capital S, as an underset of the set of natural number, capital N, we notice that capital S is non-empty, as it obviously contains the element 0. Beside that, any element S of the set capital S is lesser than the natural number a plus 1. So according to this axioma, there is an element that we will note S prime that belongs to capital S, such that S prime is greater than any element S of the set capital S. This means that there is a natural number, q prime, such that whatever the natural number q, b multiplied by q prime is greater than b multiplied by q, assuming that S prime equals b multiplied by q prime and that S equals b multiplied by q. So, knowing that the products b multiplied by q and b multiplied by q prime are both lesser than a, and that b multiplied by q prime is greater than b multiplied by q, we can deduce that there is a natural number that we will note, r prime, which is lesser than any natural number, r, assuming that r prime equals a minus b multiplied by q prime and that r equals a minus b multiplied by q. Now, this last assertion we reached that affirms that r prime is lesser than any natural number, r that equals a minus b multiplied by q, guarantees that r prime is strictly lesser than the different from zero natural number b. Beside that, the fact that the product b multiplied by q prime is lesser than a guarantees that r prime is a natural number. Therefore, we have proved the existence of two natural numbers, q prime and r prime, such that a equals b multiplied by q prime plus r prime, and r prime is strictly lesser than b. Let's now prove the unicity of the numbers, q prime and r prime. For this, let's suppose that we have two pair of numbers, q and q prime and r prime, such that a equals b multiplied by q plus r, with b strictly greater than r, and also a equals b multiplied by q prime plus r prime, with b strictly greater than r prime. By subtracting the second equality from the first one, we find that b multiplied by q minus b multiplied by q prime plus r minus r prime equals 0, and r minus r prime is strictly lesser than b. This means that b multiplied by q minus q prime equals r minus r prime and b greater than r minus r prime. So b divides r minus r prime and b greater than r minus r prime. Therefore, r minus r prime equals 0. So r equals r prime. And this means that q equals q prime. Therefore, our pair of natural numbers, q prime and r prime, is unique. So, this was how to prove the existence and the unicity of the quotient and the rest of a Euclidean division of a different from zero natural number A over a different from zero natural number B. Thank you for watching. If this has given you more insight about this topic, we invite you to help the channel by subscribing to it, liking the video, and leave us a comment in the comment section. See you soon.